report. There we go. There we go. All right. So today we are going to start looking at class components. And then time permitting, we're going to start looking at React hooks in a little bit more depth. And we're not going to get through all of the hooks today. We've already been introduced to use state. That may have been during the TypeScript session. So we'll just go over that again. But we're going to talk about class components because there's another hook, use effect, that mimics four different lifecycle methods. And those are what I really want to focus on. This is not something that you have to remember how to do, in my opinion. This is just so you could see the inner workings of these components. And then when we turn them into functional components, having knowledge of what they're doing under the hood should aid in your understanding of the use effect hook, because use effect will, like I said, mimic a bunch of different lifecycle components. And if you don't know what lifecycle components, even not components, functions even are, or what they do, then use effect, in my opinion, will be a little more challenging to learn. So we're going to go ahead and in order to save time, I'm just going to open up, where is it, in week 2? Yeah, I'm going to open up my first app. So if you've got any UI on board right now, then any one of these will work fine because we're going to be starting from scratch with a brand new component. So let me know if anybody needs a little bit more time to get spun up, but I'm going to make a new component called my class component.jsx. So we've already been introduced to components and how to make them, and this is called a functional component. This is the newer way to do it and the way that React actually recommends. And the class component will be more of an object. If you've ever messed with object-oriented programming, particularly with Java or well, any modern language really, then some of this will look familiar to you. There are lifecycle components that, as the name suggests, they'll fire during each stage of the component's life cycle. So this component will be, and I said class component, but it'll be an object that we're creating. So there's will mount, will unmount. So will mount is the function that's called prior to the component actually getting mounted, created in the DOM. Will unmount is the opposite. When it's about to unmount, that means it's about to die. So we're about to get deleted. So it may need to do some cleanup. And typically you don't need that unless you have a timer going on or something. The JavaScript engine will take care of the rest. So it's not like some languages where you have to destroy the variables that you use to store. The engine will take care of that for us. But things that you've done asynchronously, such as timers, or probably not network calls, but things that are spun off into a different thread, or at least JavaScript's version of thread, those are the kind of things you want to take care of and destroy in will unmount. And then there is, actually, I forgot to open my notes. So class components is not something that any of us really do very often anymore. This is legacy. Give me one moment to find my repo. Are there any questions on what I just said so far before we get started? I don't have the chat open. All right, and we'll also be, we'll also be introducing state. So prior, I don't remember when we went over this, but we created a button in a component that whenever you clicked it, it incremented state. We're going to do pretty much the same thing with this project. And I think that might have been the class where we had kind of an off week and we just did TypeScript stuff. So if you didn't see it, don't worry about that. We're going to do the same thing. So just like a regular functional component, we will declare it in a const. So const my class component equals, and it's a class component. Hang on. I opened the wrong notes. Okay, sorry. It's actually export class, my class component extends react.component. You can already see this is a lot more to write than normal. But we're creating a class that extends react.component. So we'll have to import React from React in order to do this, because it underlined because it didn't know what React meant until we imported it. So we got the basis for a class component. Every class component and every object, when you move into OOJ in college, we'll start with a constructor method. And the constructor method is like a factory. You call the constructor to create the new component or the new object. And that's literally going to be called constructor. Constructor will take in props, and it is a function. And it doesn't, just because this is an older way to do it, I'm using the classic function syntax instead of doing this. I don't think it likes it this way anyway, so I'm going to go back to this. But that's why this is different. So this is still a function. We're just declaring it in a different way. And we also don't need the function keyword or constant in front of it, because constructor is an overridden function that we're grabbing from react.component. So React component, I'm wondering if I could do this. Yeah, so it's got, and you can see it's deprecated in the notes. But what I just did on a Mac, you command click. On a Windows and Linux, I believe, you control click, and it'll take you to the definition for this class. So we could see we have the constructor method, and there's no implementation. This is what's known as a, it's escaping me, but it's a method that's declared, but it doesn't have any implementation to it. Because you're expected to give that implementation. And then set state, we'll look at that in a minute. There is a pure component. Now, this is too much to read through. But the constructor, again, this takes in our initial props and it creates our brand new function. This is where we're also going to create our initial state. And state is, variables that it uses to keep track of data that we're giving it, such as when we create a button that every time we click it, it'll increment a number. We're going to house that number in state and put it in the constructor. So we do need to call a super constructor. Super means, yeah, I wrote that right. Super is the superclass's constructor method. So anytime you have any one of these methods that exists in React.component already, more than likely you're going to want to call the super version of the constructor. Again, if I'm not explaining this very well, but if you don't understand it, it doesn't matter all that much because we're never going to do this again. I'm interested in the lifecycle methods, but now we can declare our initial state. This dot state equals, and we're going to do times rest, and starting state is 0. So we're going to create a method that will increment this number, and we're going to have it display this number on screen eventually. And we want to create a another function that is declared in the constructor, and it's bound to the component, to the this keyword, so we can access it anywhere inside of the component. We didn't write this function yet, but this dot handle action. Actually, I'm going to start with writing the actual function. So we're going to create a function that we will call every time we click that button, and that will increment state. So handle action. So handle action, this will be called every time the button is clicked. Action will have the event in it. So when the button is clicked, it's going to pass in the event, which is an object that includes things like the button state, or not the button state, but like a text box's state, whatever calls this, it's going to give this the event. And the event usually has all the information we need. In this case, we're not actually going to be accessing action. but we do want to see what that looks like. So console.log handle the action. And now we would want to increment state. So this dot set state times pressed. This dot state dot times pressed plus 1. So what we're doing here is this dot set state is already a function that's bound to React component. In fact, I think we saw it when I was scrolling through the code that's given to us through React.component. But set state is going to tell it, we're going to give it an object with the values that we want to change and what we want to change them to. And the way to access state is by using the this keyword dot state and then dot, whatever piece of state that we're interested in. In this case, when it runs the first time, this will be a 0 and it'll add 1. It'll save the state and this will change to a 1. Is everyone with me so far? All right, so that's all we really need to do for this function, but we also need to bind this function because again, this is a class component. This is going to reflect, the actual component, and we need to be able to call access, or rather call handle action, and we can't just call it directly, which would be nice. We have to bind it. So the way to bind it is in the constructor, this dot handle action. So we can name this anything we want right now because we're just binding a brand new function to the function that we just wrote. Handle action equals this dot handle action dot bind this. So if this doesn't make sense to you, don't worry about it because it doesn't really make sense to me. But what this does is, again, this exposes handle action to the this keyword so that we can call it anywhere in the code. So now we also need a render method. So this is the equivalent of, where's my other component? This is the equivalent of just returning the JSX, but in this case, in a class component, there's a render function that has to be called in order to spit out that JSX. We can't just return it because this isn't a function. So render, and again, this is overloaded, so we don't have to bind it or anything. And render would return the JSX code that we're interested in. And I want to, all right, I'm diverting from my notes a little bit. I want to put a button in here. So we can, do I not have? All right, I opened the wrong project. So now we have to install Material UI to get that button because I forgot about it. So cd my first app, npm I at MUI / hang on. I'm gonna make sure I send this. And I'll paste this in the Slack channel. So we need to install Material UI, and then I'm going to import the button, and I'm going to place the button inside of that div. I also have a little piece of text right above it that can show the times pressed once we run this. So import button from at MUI / material. Down here, I'll add the button. So we're creating the button. We're just gonna put the text click me, and up here we'll access this dot state dot times pressed. So that should pretty much do it. The one last thing I need to do is import my class component into app. I can get rid of all this stuff, so we could display it on the page. My class components from components / my class component. And I think I forgot to, no, I'm exporting it. So I have to put this in curly braces because I'm exporting this individually, which means it's adding it to module.exports, plural. But if I wanted to import it the same way that I'm importing my components, then I would do export default my component. So that's a default export, meaning that when you import the whole file, this is the piece that you get. Whereas if I do an export on each line individually, or in this case, this particular class, it's adding it to an exports array. So when I import it, or not an array, an object with the name my class component. So I have to do destructuring in order to grab it. I'm just going to leave this for now because it really doesn't matter which way you do. Not really, unless you have, the preferred way is this if you've got multiple components or multiple variables or whatever you're exporting in one file. In this case, I'm just going to have the one. So I could do an export default, but I'll just leave it. I can get rid of value. And there's no difference in class components when we're referencing them in JSON or JSX. So this is all you need. And we're not giving it any props, but when we give it properties such as, I don't know, something equals something, this would show up in props. We're not using props. So now I'm going to run this. npm run start. And also there's no, once it's transpiled into code that the browser can run, there is no difference between a class component and a functional component. They both do almost exactly the same thing. It's just the way that they're written. So there's no performance boost or anything in creating class components at all. Functional components, that's something newer that was introduced a few versions ago, along with React hooks. And that's just a more concise way to write the exact same thing. Come on. There we go. All right, so we got the button. We don't have it hooked up to the action yet, so times pressed is not updating. And I'm actually going to add a div to times pressed so that it doesn't show up in line like this. And I'm also going to change the button. So I can change the button with variance equals contained so that it gives it a nice border. And I'll wrap this in a div. Cool. So now we want to actually call handle action. So button has on click property. So on click equals handle action. And I'm also going to open up the, this dot handle action. Because remember, we can't call handle action directly. We have to use this dot handle action. And then if this isn't bound, this won't yell at me, but when I click the button, nothing's going to happen. That's because it is calling, it's actually calling undefined as a function. And we're probably getting, we're probably getting console errors when I press the button right now because it's not bound. Yeah. So it doesn't know what I'm doing right now. So let's uncomment this dot handle action. So now when I call it handle the action, we're going to see what it actually gives the handle action function. So we have a synthetic base event, and it's going to give us all the information about the event that we may need to know and more. So we know that that action type is click. We can see exactly where on the page it happens, so you can use that if you need to. But in our case right now, we're not doing anything with the event, but when we're working with text fields, we would. And we can also see when I click the button, this changed. So every time, and it's just like use state, every time we call the set state function, it actually triggers a re-render of the entire page. This gets re-rendered, and this JSX is refreshed with the new value of this dot state dot times pressed. So does everyone understand kind of what's going on here? So that's a lot to write just for something really simple, right? And we can add additional pieces of state. And I can also show you that when you call the set state function, under the hood, it's taking this object and it's doing a spread on it. So previous state and new state. So you don't have to give it the entire state object, and we're going to add more keys to this so you can see what I mean. But it takes whatever the previous global state was, this entire object, it spreads it out, and then it takes whatever you give the set state function and spreads it out so that all previous keys still exist when you add new state. So what I mean by that is some other state, hello. And after this action, well, actually in the render function, I'm going to console log this dot state. So you can see that when I update state with or update times pressed in state, but I don't give it the other key, it's still going to retain this key and not change its value. And I'm pointing that out because sometimes I see some other state, this dot state dot some other state. Some people think that they have to continuously give it the entirety of state every time set state is called. So that's not needed. And we can also see how often this thing re-renders. So I'm going to click this. Here's state. We edited times pressed. Hello is still there. Click it again. Same thing. And I'm going to keep that console log with state in there. Actually, I'm going to replace this dot state with re-render. So when we start looking at lifecycle methods, you could see how often they can potentially re-render something. And I also want to keep this for when we do change this to a functional component in a minute. So the lifecycle methods. So each component's independent. We already looked at nesting. States asynchronicity. So set state is an async function, so it may not update immediately. I don't know if this returns a promise, but it creates a new thread where it's updating that state. And then once that state is done updating, it'll tell React to re-render. So if I were to console log times pressed immediately after it, we're going to see the old value. So you don't want to do any actions with that require the use of the brand new state immediately after set state is called, because it's not actually going to call. So console log this dot state dot times pressed. I'll put this as hello so we could see where it's actually console logging. So when I press the button the first time, it's going to console log, the event. We're actually going to go ahead and get rid of this. I'm actually going to comment it out because we're going to use this again in a minute. Set state is called, and then the rest of the function will finish before it's done updating. So when I press that button the first time, with the initial state being 0, we're going to see a console log. And because we're kind of used to an imperative flow where, one execution fires after another, we're going to expect this to say 1 because we just updated that state. However, when I click the button, we're going to see 0. Right now it's 1. I click it again, we're going to see 1. We're seeing the previous value. So we don't want to do any logic that relies on an up-to-date state in the handle action function. That needs to happen in another function. And there is a lifecycle method for that. So let's see. So reset to 0. So we can copy that, or I cannot copy that. I'll just type it out. But reset state to 0, it's self-explanatory, but when this is called, obviously it'll set state to 0 again. I'm going to skip a lot of this just because it's not really needed. All right, so we'll start playing with text fields. So text fields, we're going to be creating, we'll use some other state and we'll set this to an empty string at first. We're going to bring in a text field and add it after our button. Actually, this is self-closing. There we go. So we have our material UI text field, and right now it's not connected to any state, so it's just going to retain its own. But we want it to update state with whatever we type in here whenever it's pressed. So this is where the event object is going to come in handy. So I'm going to uncomment that line where we console log the action. Actually, I want to make a new function. So I'm going to make a brand new function that'll handle typing in that text box. So this dot handle text change equals this dot handle text change dot bind this, and then we'll create that function handle text change. I'm getting a white page error because I didn't actually create that function yet, and now we're back. That function exists and is now bound. We're going to console log the action. And same thing, this dot set state. And we don't actually know what to set state to yet because we need to access the action to see what that new value is. So for now, we'll just console log it. And the text field itself has on change equals this dot handle text change. So now every time I type in here, I will see an event. We'll look at the latest one. So the event that's sent by text field is a little bit different. There's less values. We have to access the actual target, which target is usually the actual component where the event fired from. So that'll be in target. And we can see a lot of stuff about target, but what we're interested in is value. So the value right now is 1, 2, 3, and we want to set that to state. So this dot set state, and I named that some other state, action dot target dot value. And I'll console log state. This dot state. All right, so we could see some other state is getting updated with 1, 2, 3. And we also want to connect state directly to the text field. And although state is asynchronously kind of updating as we type stuff into the text field, we also want to set the text field's value to state. And the reason for that is, well, right now we just have an empty string, but if there is a starting value, such as my name, that wouldn't show up. That state will get erased as soon as I start typing in here, and it's obviously not set in the text field. So we want to set value equals this dot state dot some other state. So when I reload the page, I should see the starting state is Mike, and the text field is both updating and reading from state dot some other state. And we could see that by console logging it. So are there any questions on that? All right, so that's the very, very basics of state. And as far as state goes, there's not much more that you can do than this. But creating one of these actions for every piece of state that you want to change, that's a little repetitive. And with the new functional components in the use state hook, it's no longer needed. But we'll rewrite this function or this component as a functional component. You can see how much less code it ends up being. But let's also get into lifecycle methods. So I have to scroll a little ways for this. Oh, you know what? That is a different PDF that is in lifecycle methods. All right, so there are phases to a component's lifecycle, and the first thing is mounting, which we've already taken care of. There's the constructor method, which is called before the function or before the component is actually brought to the page, it's spinning it up, it's creating it and setting its initial state like we do here. And that'll go off of props that we give it. So that'll be things like, whatever props we give it in app.js. If we have a username and password field, maybe username is, you're on a website that remembers the username, its initial state is going to be that username. And you would set that in the constructor. There's also get derived state from props, and it's invoked before the render method on both the first mounting and every following update. So what this does is, all right, we've given the props to the constructor method, but as soon as the class component's created, it's in memory, and maybe something in app.js changed, the prop is changed. It's not going through the constructor method again. The constructor has already been called. It's only called once until this component's unmounted and it's remounted back on the page. So we would not get any sense of the updates. That's why we need get derived state from props. So if I were to add a prop to app, such as some prop, that would now show up in the props object here. So if I console log this, and reload the page because I deleted it, we see props, some prop, hello. But if that prop were to change at the app level, because maybe app has its own state, then without this get derived state from props function, we would never get any kind of updates. So we have to write a function for that. And in this case, I'm not changing some prop at all. I'm not going to add state to app just to show that, but it would look exactly like the constructor. And if I'm not mistaken, you have to use this dot state as well, or this dot set state instead of this state equals. I think you can actually use either one, but you have to write a method specifically for when props change, depending on what your class component is supposed to be doing. Remember when I talked about the difference between controllers and components? The controller is usually what houses the state. The component is simply what displays it. In this case, that would actually be kind of difficult to do because we would have to write that function to handle prop changes from a component, which is also storing state. So that's actually not really applicable in this case, but that makes your class components that much more complicated because the logic and the state have to be housed together. And by logic, I mean the render logic. Render, again, this is something we already went over. And I forgot to mention constructor and get derived state from props. Neither of these are required. These are only required if you are actually using state and actually using props. Render, however, is the only method that is required because it is a React component. It's expected to be outputting some kind of JSX code to display on the screen. So render is required. If I were to comment this out, I'd actually get a white, well, none of this would show up, but I would get a white page error because the render method isn't here. And we could see that in the console. Instance.render is not a function. So it's trying to call render, but we haven't declared it. So it's undefined right now. So that will cause a white page error. If I have other components on this page, then those won't show up either. White page error means that the website crashed. It doesn't know what to do. It's unhandled. So it's got to just print to the console and wait for you to fix it. And component did mount. This is invoked as soon as the component is mounted to the DOM, as soon as it shows up on the page. And if set state is called in here, and I'm not going to demo this, but if you call set state inside of component did mount, which you should not do, it's going to re-render twice. And that's not really a big issue, except in a larger app where you have a lot of different components and triggering a re-render in one place may trigger a whole page re-render. So you want to be careful with that. Component did mount should really only be used for like creating timers or stuff like that. I don't really have a use case for this off the top of my head. I personally have never used it, but this is set. Oh, you know what? Actually, one place that this would be used is to call network functions. So if you have a component that shows, let's say, the price of a stock in the stock market, and you want it to be self-contained, so it's going to make that network request itself, which you shouldn't do, but option exists. Then you would do it in component did mount. As soon as it's got its state all set up and it's in the DOM and it's ready to go, that's where you would want to make a request out to NASDAQ or something to get the price of the stock. That's where component did mount comes in. There is component will mount, but it's been deprecated, meaning that, and I think it's still in the code base, but you shouldn't use it. That's telling the component what to do prior to actually getting added to the DOM. And I suppose the use case for this, again, React deprecated it, so component did mount is probably better anyway. But component will mount would have been for making those network calls and getting state all set up prior to actually being added to the DOM. In this case, it wouldn't trigger re-render because it's never rendered yet. So that's what that would be used for. Updating, we talked about updating. Unmounting, so component will unmount. This is where the component is about to get removed from the DOM. It may have to do some kind of cleanup. More often than not, you really don't need this, but it's good for dealing with closing out timers if you set them. Like if you have a page that automatically refreshes every 15 seconds, then this is the place to get rid of the timer, as long as you have the timer itself set in state and is accessible by the component will mount. And maybe not state, but at least bound to this keyword. And then we have some other methods that don't really have functional analogs, so I'm not going to spend too much time on them, but get derived state from error and component did catch. So component did catch, if we get that white page error because they removed the render function, component did catch would be the place to handle that error and prevent a full white page error crashing the entire website. This function is used to contain an error to one specific component. So let's say you're making that network call to call NASDAQ. Maybe NASDAQ is down for whatever reason during a catastrophe. NASDAQ's APIs are always up because everybody, the whole financial world depends on that. But let's say NASDAQ's down. You make that network call and you haven't handled a case where the network call fails. That would crash the component, and the component's crash would crash the entire web page potentially. So here you would have a component did catch to handle whatever that error was and allow the page or contain that error to just that one component, allow the rest of the app to continue. And here it would be like an alternate render or alternate state rather. So and really, that should be handled in the functions that are actually making those calls, but that is why this exists. So that's pretty much it for the lifecycle methods. And we're not going to, like I said, we're not going to demonstrate them just because I want to get to actually, use state and all the fun stuff. So let's go ahead and create a new file, or I could actually copy it into my component because this isn't doing anything. So I'm going to copy all of this and paste it into my component so that we can compare when we're done. But we're going to rip all of this out and replace it with its modern counterpart. And you can see how much less code you have to write. And keep in mind, we didn't even write everything that's required because we need to add derived state from props, but we're not too worried about that right now. All right, so first thing, we can get rid of export class, blah, blah, blah. We can change this to const equals my class components. Not const equals, my bad. So we're changing this into a function. We're gonna replace render with return. We're gonna get rid of this. And we're gonna keep just the return clause out of the render function. We can get rid of the constructor, but we still want initial state. So we need to pull in use state from the React library. So React use state. And we got two pieces of state here. We got times pressed and some other state. So const times pressed and set times pressed. I'll talk about this as soon as I'm done typing it. So use state, this function takes in one parameter, and that is the initial state, in this case 0. It returns an array of exactly 2 items. So we can use destructuring to grab those 2. The first one is always going to be the variable that stores what the actual state is. And set times pressed is a setter, which will, when invoked, do exactly the same thing as this .set state, except it's only worried about this specific piece. When this is called with a new value, this will update, and times pressed will have the new value in it. And the other piece of state was const some other state, set some other state equals use state, and the initial value is Mike. So now we can get rid of the constructor. In fact, we can get rid of handle action and handle text action. We can set, we could replace this .state times pressed with just times pressed. We can do the same thing with some other state. And this .handle, this .handle action is what I had for updating the times pressed. We're going to give it an anonymous function because we have that, or no, we don't even need to do that, do we? Set time, yeah, we do. Set times pressed plus 1. So we have to give it an anonymous function because if I leave it at this, it's going to fire every single time a re-render happens, which will cause a chain reaction. When this is called and this state is updated, that's going to tell React to re-render, and times pressed is just going to go up to infinity, basically, until the computer crashes or the sun burns out, whatever comes first. So we want to give it an anonymous function so that it's not invoked immediately. And this is the same thing as writing const handle action equals set times press plus 1. In fact, it might be preferable to just declare a separate function specifically for that, but I like one-liners, so either works. I'll just comment that out. And same thing for handle text change. Now, handle text change, remember we had that action that we had to worry about. It's the same thing with right here. So in this case, I like to call it event action, whatever your preference is. Set some other state, event.target.value. So if we load the page and we include my components, and I'll have a div to separate it so that it's clear which one's which. Height equals 20 pixels. So they're nice and separated, and we're not giving it any props. I could just delete this because we're not using it. Oh, yeah, so we need to wrap this in curly braces because we're only exporting it as a singular instead of making the entire, we're making the default export, and then we've got, so we have my component, my class components. They're both exported as singulars. Oh, because I didn't rename this. There we go. All right, so up here we've got the original class component, and down here we have the new functional component. As you can see, they do exactly the same thing. They each have their own independent state, except I'm, console logging, but they do exactly the same thing. And you can see the difference in code, and I'll open this to the right. And minus the spaces and everything, you can see how much extra you have to type to achieve exactly the same thing with class components. which is why we don't use them anymore. But it's important to know how this works under the hood. Use state under the hood. When it's transpiled, it's going to spit all of this stuff out. It's going to bind the handler, which in this case is set times pressed, handle action, whatever. There's no this dot set state anymore that we have to worry about. Use state handles that for us. Initial state, same thing. It's setting initial state for us. We just give it as a parameter. And we don't have to write handle action. We can easily set them as one-liners in here, although you still have the option to do that if it's more clear to you. No wrong way. And render function is pretty much exactly the same thing, except it's a return block instead of a separate function. So you can already see how this is better. And this would, again, be even longer if I had the function written to handle prop changes. But in this case, we're not using props in either one of them. But again, we don't have to have that function. That's replaced with my prop, just declared destructured up here. So are there any questions on that? You can also see in legacy code, it's really easy to convert it because up here, when we're importing it, React doesn't care whether it's a class component or a functional component. They're interoperable because I am running both of them in the exact same project. So if you ever run across a legacy project that still uses class components, you can bump up the React version to, I believe, 14 or above. I'm going to say 14. I don't know that off the top of my head. And you can rip out all of its state stuff with just use state. So now we're going to play with my component a little bit more and add, and I want to show you the infinite loop thing that I was talking about. So this will re-render several hundred times. So times, and I don't know if it actually triggers or if it actually shows the re-render on the page, which is why I'm going to also console log this. But I do know for a fact that this console log is going to run forever. Every time it re-renders, everything about this is run again, except it doesn't reset our hooks. The hooks will retain their state. Everything else will run all over again when a re-render happens. And I'm going to take away the anonymous function declaration here. And turns out it caps it. I thought it would just keep on going and it crashed the entire page. If it did update the page at all, we didn't see it, but you can see that every time the re-render occurred, it gave this function, but because we're giving it parameters, we have parentheses around it. It invoked this function. It then, it actually called the setter, the state updated, state told React, hey, there's an update, you need to re-render. And it just kept on going until React actually stopped it at only 35 actually. In the previous version, probably 17, I was able to actually, not 17. What version are we on? I'm going to say 15. I could have actually had this go on forever and ever. So that's something you got to be careful about, which also might be why it's preferred. You may prefer to just make functions like this because there's no possibility of that happening if I give it this function, unless I actually invoke it with the parentheses. And we could see that the page disappeared again because it did the infinite re-render. When I gave it its parentheses, when I took them away, all's good. I can click the button, it calls that function. So does everyone understand why that happened? Cool. So now how do we achieve lifecycle functions? So lifecycle functions are handled with useEffect. UseEffect is, it's named because useEffect usually deals with side effects. Side effects would be things that, well, let me take a step back. A function is considered pure, meaning there are no side effects if no matter what you give it, it will always give the same return, meaning a function like this, const add equals num1, num2, return num1 plus num2. This here is a pure component, meaning that if given the same inputs, it will always give the same output, always. You can run this infinity times, it'll always return 2 plus 2 is 4, right? A side effect would be something that happens that can be different every time you call this function. And that would be stuff like a network call. Hitting the same URL a million times won't always give the same results. There could be a 404, 500, or simply no response because the server was taken down. That's called a side effect. Same thing with reading files. That's a side effect because if you do it multiple times, you're not guaranteed the same result. So use effect is, and this component right now, this is a pure component. It's going to return exactly the same thing no matter how many times I call it. It's going to return an object with state of 0 and mic, and it'll have all the buttons and everything. Right now, this is a pure component. Use effect is a way to add side effects and only call them however many times you actually want to call them. So in the case of network calls, you don't want to make network calls every time the page re-renders. So like when I did console log, every time I press one of these buttons, it's going to trigger a re-render. And that re-render is going to call everything that's not a hook outside of any blocks. If I only wanted to call once on page load, I would use effect. So use effect. Use effect takes in a function, and that's the function that'll be called whenever a set of variables either changes or whatever. So there's 2 parameters. The first is the function, the second that it'll call. The second is a list of dependencies. Dependencies meaning variables. So if I were to want an effect or like a network call to happen every time times pressed was triggered, I would add times pressed to this dependency array here. Every time times pressed changes, use effect knows to run whatever this function is. This may be a network call. So, when you go to a website and you can change stuff on the website, on the back end, it is sending network calls to update whatever it is that you're changing. Or Google. Google's a great example. When you start typing in Google, it'll already give you a list of suggestions. It's getting those from network calls. Every time you add a letter or a number to whatever it is you're typing, it'll fetch another set of suggestions. So it's probably, well, I don't think Google is written with React. They're probably written with Angular, but it's the same concept. Anytime your search input is changed, it's going to call a use effect had it been written in React. So console log doing the thing. So this won't actually, or I think this will, yeah. So this will fire at least once. And if I change the text, and in this case, I'm editing the some other state, it's not in the dependency tree, this will not run. You see doing the thing is not printing, but when I click this button and I update times pressed, it's doing things. So that could be a network call, it could be a file save. Well, probably not with React, but for the most part, it'll be a network call. And if I only wanted to run once and only once on page load, this is akin to component did mount, then it would only fire when I load the page, but nothing else I do will cause it to fire again. So that could be, again, that could be a function call, that could be any number of things. Maybe we're talking about that component that, grabs a stock price. You only want to request that once, unless you click a refresh button or something. And it would grab whatever the price is and display it. It would only load once unless you click the button. And that brings me to the next thing. Use effect is not asynchronous. So we haven't talked about async await too much yet, but async await would be used for so asynchronous functions. That would be things that return a promise being a network call. It's not something that's going to fire immediately like everything else that we're writing. It's going to take time to complete. So it's going to return a promise, and a promise object simply means, this will eventually be a value of some kind. File reads or this isn't really something we worry about in a UI, but accessing the file system, that's another thing that would return a promise, because reading the disk might take some time. So using async await, that's blocking code. And we're going to talk more about network calls a little bit later. But in this case, we're going to make a network call to the Pokemon API that I think I talked about a little bit ago. And we're going to demonstrate, and I'm going to try to not DOS them. And I would ask that you don't either. But we want to write a function that will make that call and update state in some way. So I think I'm going to set this to Pokemon name and set Pokemon name. And I can get rid of this text field for now, as well as times pressed. So I'm about to make a network call, and I can get rid of the class component as well. So the thing I'm about to do is, right now state is 0. There's no like 0 with Pokemon, so I might want to increment that. But every time I click this button, it's going to give me a different Pokemon name up here in order, right? So we would want to use the Pokemon API. And I'm not going to go in depth with the Pokemon API. I'll just write this function and provide it to you. Const retrieve Pokemon name equals async. I don't have super agent on board. So we need to download super agent. So kill the process, npmi super agent. It should load a lot faster than before because it should be cached. So super agent is a node module that allows you to make network calls. It's already warning me about some stuff here. That doesn't matter. But what super agent does is make network calls, and it's pretty easy to use. Const super agent equals requiring, oh, sorry. Context shift. Import super agent from super agent. I'm making this an asynchronous function. Const result equals await super agent dot get, and Pokemon API. We talked about this briefly during the TypeScript class if you weren't there, but the Pokemon API is just a free API that I like to use for demonstrations that is free to use. You don't need an account. Pokemon / So in this case, we'll just hard code it to 1 for now, console log results, and retrieve Pokemon name. So this is an asynchronous function. Again, it returns a promise. Eventually that promise turns into whatever data is returned from this network call. And this use effect, if I were to put await in front of it, normally, await will halt execution of everything until the promise resolves, until the network call is responded. And use effect doesn't like these. Unexpected reserve word await. Use effect doesn't like to wait. So it's going to ignore this await keyword. In fact, it may very well throw an error. Yeah, so it won't even run the page anymore. It used to do it, but weird stuff would happen. So I just have to call it without awaiting anything. This will create a separate thread that will, wait for this to execute. And I should have the response object. I'm not gonna explain what's in this response object. I'll just type, because network calls is a little bit later, but result.body.name, Bulbasaur. So this is the value we want up here. And every time I increment every time I click the button, it's going to increment times pressed. And times pressed is actually going to be used to fetch the ID for the Pokemon. Times pressed. We'll just replace it with fancy ticks. If you don't know what these are, they are the ticks that are above the tab button on the left side of your keyboard. and we're using $ brackets to add times press to this URL. So on first run, nothing's going to come back. It's actually going to be not found because there is no Pokemon 0. I could fix that by setting the initial value to 1. And I'm also going to do that. And I'm going to use the set Pokemon name function immediately after this network call to update that text. So set Pokemon name, and I'm already console logging result.body.name. So now when I click this button, well, right now I don't have any dependencies. So when I click this button, it's not going to trigger a re-render, even though state is updating, and I could put a console log to prove it. But right now, nothing's happening to the page. In fact, actually, that network call wasn't being made at all because useEffect is only set to run once because this array is empty. So we can set this to fire off when times pressed is changed, because times pressed being changed affects what happens here. So we add it to the dependency array. And right now it's saying it's missing retrieve Pokemon name. You can ignore that because that's the function we're calling. But yeah, now that I set that useEffect to fire whenever times pressed is changed, I can click this button and we're getting the next Pokemon. So that's what useEffect is primarily used for, network calls. useEffect can also be used to create timers. So in an app that I'm writing that's not on this computer, so I can't show you, I'm having the page refresh itself every 15 minutes. So what I'm doing is I'm creating a timer. In fact, I'm going to do exactly the same thing in here. So I'm going to create a new timer function, set timeout. Set timeout creates a new thread, and right now it's crashing because I'm not actually giving it a function. But set timeout takes in 2 parameters. The first is a callback function. After the elapsed time, it's going to call that function. And I'm actually going to use something other than set timeout, set interval. Set timeout only runs once. Set interval continues to run. And again, it takes in 2 parameters, the callback function and the number of milliseconds to wait. And what this does is it calls that function every, however many seconds I give it or milliseconds I give it, and it'll just continue. But it creates this in a brand new thread. So when this component is unmounted, this timer will just continue. In fact, if I do this incorrectly, it's going to just continue to fire, which I don't necessarily want. So, and I'm going to do this to retrieve next Pokemon name. So I want retrieve next Pokemon name to, retrieve that Pokemon name like we were doing before, but also increase times pressed. In fact, I'm going to get rid of the button. But it's going to increment times pressed after it's run. So the next time it runs, it's going to retrieve the next Pokemon in the list. So at the end of this, I'm going to do set times pressed to times pressed plus 1. And I'm going to attach this to a timeout. And I can just simply give it this. I don't have to actually, do the parentheses, brackets, or anything. I can just give it this function. We can see right now, times pressed, it's in an infinite loop. In fact, I'm going to stop this before I DOS the Pokemon API. It's caught in an infinite loop. Uh-oh. Yeah, it's still continuing. All right, so I'm going to comment that out before Pokemon API crashes. So that was because of set interval. But what happened there was retrieve Pokemon name fired. It increased times pressed and you saw it cycling through. I just didn't give it an interval amount. By default, it's 0. So it's just going to call this as many times as possible. So before I uncomment it, I'm actually going to add 50,000 milliseconds so I have time to write this. but it was triggering a bunch of refreshes and bad things were happening. I think it's safe to undo that now. So the use effect itself is only going to call, right now it should only be calling once. I don't know why it keeps doing this. Anyway. So anyway, we're setting the interval, and I'm gonna not uncomment this until I'm sure I have this fixed. But use effect also has a return value, and a return, whatever you return is what it will use to call component will unmount. So that's the cleanup function. So use effect is kind of confusing in this manner. We're actually returning a function at the end of this use effect. Return. And this will do interval dot, oops. I don't want to uncomment this. I'm actually just going to kill the process. Interval dot, I don't remember what the, let's see. Set interval JavaScript destroy. Let's see. Clear interval. So it's a separate function. All right. So what we're doing here is use effect is fired and it should only fire once. It's going to create the interval. The center interval is going to create a new thread, and it's just going to continuously call retrieve next Pokemon every 50,000 milliseconds. Once the component unmounts, it's going to fire this function. This is the cleanup function that we're returning inside the use effect. And that's going to tell it to destroy that interval so it stops running. And that's that. So now when I rerun this, it shouldn't be DOSing the Pokemon API. So you got to be careful with that kind of thing. Not doing that. It's not showing anything on the screen for some reason. Why? Okay, it is. Oh, and I also have to run it the first time as well. So retrieve next Pokemon. Why is it only running once? Oh, because 50,000 is kind of a long time, isn't it? So let's do that every 5 seconds. 1001, 1002, 1003, 1004. 5,000 milliseconds is 5 seconds, right? Oh, it's just calling 3 over and over again. That's why.
Oh, sorry. I was finding my unmute. Yes, you are correct.
So this is not updating. Why is that? Times pressed. Oh no, that's going to set it. That's going to just get faster and faster because I'm creating a bunch of different timers.
Go back to your code, Mike. So use effect, we do have the function defined. We invoked it once. And then you have interval. set the format for interval though?
I'm pretty sure it is. The first one's the callback function. And the
Okay.
second one is number. The callback function, we see the network requests are happening. Oh, wait, I think,
It's increasing now. Yep. Yep. Oh, okay.
no, it is. I just refreshed the page.
But the
Well, it is calling every 5 seconds, but for some reason, it's not incrementing times pressed for
Let's-
some reason.
let's try this format once. I don't know if it's issue with the format, but I'm pasting it in chat. Let's compare that. Or maybe you're already doing that. Just let's compare once if it's in the same format or not.
Why did that? Oh, I see. So set
The only-
interval.
Yeah, the only difference I see set interval, they're defining a function there itself versus you're just invoking it, right?
Well, I'm not invoking it. I'm giving it just the function. It's already
Oh.
prepared up here.
Yeah, you might. Yeah. It might be weird with it being out of the use effect. Like you might need to use callback around it or something.
Maybe. Yeah, because it is calling every 5 seconds now, but it's calling the same IDs. So it's not
Yeah.
incrementing state for some reason. And I'm not sure why.
I think that's more of a React thing than a JavaScript thing. So I think it has to do with the use effect and how it can be a little weird.
Yeah, so
Your
anyway.
dependency array is good being empty.
Yeah, it's good empty because I only want this to fire off once. Because if I don't do that, it's going to create a bunch of different intervals.
Yeah.
Although I'm going to try giving it times pressed and see what it does.
I think the easiest thing might be if you move the function inside of the use effect.
That's working now.
This should only, this
Perfect.
isn't working because it's creating a bunch of different intervals. This should only be firing every 5 seconds.
Try moving the function inside the use effect.
Can't do that because it's asynchronous.
You should be able to.
Yeah, you can define async function inside that.
Oh, you mean just defining it?
Mhm.
Define it, yeah.
Yep.
Okay.
Yeah, no, it's still not incrementing.
And do we still have that times pressed defined there, or did we move that? Can you add times pressed there in the array below?
No, because that'll create a bunch of different intervals every time times pressed is updated.
It's every five seconds.
Yeah, now it should happen every 5 seconds.
Well, no, because every time times pressed changes, use effect is going to create a brand new interval, and we're going to have, you know, infinity intervals running. That's why it was going really fast. Right now it's updating every 5 seconds, which is great. But when I added that, when I added it to the array, it was pretty much accelerating.
Oh, yeah. You don't want that.
So it's creating a bunch of different intervals in memory right now, which is not good. So I'm not sure what's going on there. Although one thing I could do, I could go ahead and just use set timeout. Clear interval and do times pressed so that it can run multiple times. The set timeouts will only fire once. That's not doing any good. Yeah, that's not it. Whatever. I'm not too hung up on this. Anyway, you can see how this would work. For whatever reason, it's not updating state. But
Mike, we try one more thing. When you're setting times pressed, sometimes if you take the argument passed in, so the previous times pressed, and the arrow function previous times pressed +1, it can work around this because in the use effect, times pressed may not be referencing the right value. So are you sure you're incrementing that times pressed?
Well, times pressed is being referenced from use state.
If you go to the network, are we making network calls every 5 seconds?
Yeah.
It's just the times pressed is not incrementing, right?
Yeah, it's just not increasing.
If you replace that with a previous arrow previous +1, I think it will work.
Well,
On
that
line
would have,
21.
you would have to make this recursive.
I think so. It's an option with set states. I'm gonna
I'm
type
not-
in chat.
Yeah, I'm not sure I understand.
Just on line 24 or 21.
21.
Yeah.
That state. Oh. Previous.
But with our set times pressed set state.
And then is set state something that's included in React?
No, just the set times pressed that we're already using. Like if you change the inner part of that function.
Oh,
call.
I see.
Yeah,
This.
yes. And yeah, that should not have a meaning.
Well, that kind of worked. I don't know. No, yeah, no, it's not incrementing. I'm gonna change this so that's, I don't know if the variable name is colliding. Yeah, it's only changing the name when it's re-rendering. Yeah, I don't know. Anyway,
Do we need to add that logic inside set interval? Or no, we just did that, right? At the end, we are incrementing it and then we are setting it.
yeah, it's already inside of
Okay,
that interval.
alright, yeah.
Well, I'm stumped.
And handle it.
Does the set times pressed need to be passed to the dependency?
That
Alright.
could be, yeah, set times pressed. And times pressed. No.
No. Well, interesting problem you came across here.
Yeah, I don't know what's going on here. Anyway, what should, oh, well, why don't we do this real quick, times press +1. That's only doing it with re-renders. What the
No.
heck? And I don't want to add times pressed here because then it's going to create a bunch of different intervals. Well, whatever. You see what I'm attempting to do at least. I guess you can't really increment here, but because for whatever reason, this isn't firing properly, or maybe times pressed in scope here is not changing. I don't know why, but we do see that the network calls are happening every 5 seconds, and that's something that useEffect does. And if I were to take this component off of the DOM, it's dismounted, then that interval is destroyed because I'm returning this function. This is the cleanup function. So this is similar to component will unmount, which we didn't create in our class component because we didn't really need to, but that's what this does. Most of the time, unless you're doing a refresh like every 15 seconds, like, kind of like this, then, without state changes preferably, then that's what you would need to do. But otherwise, cleanup is pretty much done. Anything that's destroyed inside of this useEffect by default. So use interval or set interval rather creates a new thread, but calling retrieve next Pokemon doesn't. So you don't need to worry about destroying these. In fact, if we didn't have this interval in here at all, and I can just get rid of, or I'm going to keep that in there. Then when this is unmounted, then everything's already cleaned up. Anyway, other than stumbling through this problem, I hope everyone kind of got the hang of use state, and I'm going to get rid of set state and understand how it works. useEffect, this is something that you can use in a variety of different ways. But like I said, for the most part, it's for side effects such as network calls and file reads. We're going to talk about use reducer next week, which is like use state, except it creates a I don't know what to call it exactly, but it's an action-based state system. So you can update multiple pieces of state at once, only causing one re-render. If I were to, inside of this use effect, and I'll demonstrate this real quick, console.log re-render, and I'll get rid of this stuff. Set times, actually, I don't even need to use effect. I can just uncomment this stuff. Whoa, something weird happened. There we go. And I changed the name of this. If I were to have a handle action that updated both set times pressed and set Pokemon name, we're going to see the re-render function happen twice when I press this button, and I'll just clear out all this stuff. Whoops. Oh, maybe they fixed that. Anyway, in the past, setting times pressed and setting Pokemon name would cause two separate re-renders, which is something that use reducer would have handled. But now use reducer can be like a state machine where you only need to pass in one action and it'll update multiple pieces of state. And that might be useful for, well, in this app or in this piece of code, it wouldn't really help all that much. But when you're handling a lot of different pieces of state that may interact with each other and in most cases are updated at the same time, that's where use reducer would come in. And it also saves you a lot in prop drilling. So we haven't really done any nested components yet, but once you make more complicated components with multiple props like what we have down here, and let's say this text field for whatever reason is using, let's say we have 50 pieces of state here, you would have to prop drill every single one of them. And if you have a component inside of text field that uses some of that state, then it's going to get complicated really quickly. Whereas use reducer, it has the entire state object in one variable, and you can pass that down as deeply as you need to without having to worry about copying all 50 variable names and adding them down as props. So this is a problem we haven't experienced yet, but we're going to go ahead and go into use reducer next week anyway to present that as a solution you can use. Are there any questions on today at all? And remember, if you don't remember how to do this, it's no big deal. This is archaic. I was just doing this to show you how much better and how use state works under the hood as well as use effect. I see nothing in the chat. I'm hearing no voices. All right. I will stop the recording. That concludes